Hello, today we are going to discuss really interesting topic that is time series forecasting. Let me quickly show you the agenda for today's video. This is the agenda for today's video. In today's video, we are going to discuss all this topic: introduction of forecasting, time series analysis, types of forecasting, and what are the components of time series forecasting. Finally, the list of time series model. So this all topic we are going to cover today. So watch my video fully and pay attention to this video. First one is introduction of forecasting. So first of all, what is forecasting? Forecasting is nothing but making prediction for future event or future observations based on historical data, that is past and present data. Okay, forecasting is one of the technique in machine learning that can predict future events based on the historical data. Let's say, for example, we can take a weather forecast. So we want to predict whether how the weather will be next month or Feb month. So Feb one, what is the weather that we can expect? Whether the weather will be cloud or mostly sunny or partial cloudy. All the things we can predict using time series forecasting, and also we can predict the stock price or sales price and ticket volume forecasting. So all the use cases we can do using time series forecasting. Most of the use cases we can do using machine learning and deep learning models. Let's quickly discuss about some deep dive into time series analysis. Time series analysis is one of the statistical method or technique that can deals directly with time series data. So in time series, the index column should be date and time. And one more thing, before we train the model, we have to analyze and find the patterns in the historical data. So we need to know, right? We have some 10 years of data. So we have to analyze how the trend for 10 years of data and what will be the, is there any seasonality or cyclicity for past 10 years that we can give additional information to the model when we do training. Okay. Types of forecasting. We have two types. One is univariate forecasting and another one is multivariate forecasting. We can discuss quickly what are the difference between univariate and multivariate forecasting. Univariate means name itself says uni means one, multi means multiple inputs we are feeding to the model. Univariate, we are passing only one variable, and in multivariate, we can use multiple variables. For example, we can take a weather forecast. We have weather column like sunny or cloudy, that based on the date. Okay, our index column will be date, right? Each day we can have the weather how in the historical data. Additional information also we can pass like the temperature, humidity, and the wind speed. If you want to pass additional input, we have to use multivariate model. Okay, we can't use some single or univariate model. Mostly multivariate and model will be preferable for most of the use cases. Let's quickly discuss what are the components of time series model. When we analyze the data, we have to analyze these components. First one is we have to analyze the trend, seasonality, and the data is stationary. That is one of the main thing. If your data is not stationary, then we have to make our data stationary. Okay, trend something, it's a pattern that represents the variation of frequency over a long period of time. We can see the pattern for 10 years, like we have the data set having 10 years of data. We need to analyze the trend, how the trend will be over a long period of time. That we have to analyze it, and we can uh, pass the information to the model also. You can like seasonality. Seasonality is nothing but there are some variations occur in certain interval, like monthly or quarterly or yearly. If we have a 10 years of data, we can see first 10 years how the sales will be, and what will be the sales for 11th year or 12th year, or that we can say, right? Based on the seasonality, season there could be vary. The sales will be vary, right? All the thing we need to analyze, and we can see what is stationary. Stationary means that constant, the data having constant mean and constant variation. If your data is not having the constant mean and constant variation, we have to make our data to stationary. So in this graph, you can see in the green line, This is the stationary data pattern. Here you can see that there is a constant mean and the constant variations. In the next graph, we can't predict, right? There is no constant mean and variance. So that it's ongoing trend, and this is going downwards and up and down. So this is non-stationary data. If your data is not stationary, we have to make our data stationary before feeding or training the model. How we can make? There are a lot of statistical methods are available. Models are available, like a Dickey-Fuller method we can use based on p is something, but that is one of the parameter, like significance levels, that we can check whether data is accepting the null hypothesis or rejecting the null hypothesis, that we can check. Also we can use it for stationary data checking, like if the p-value is less than 0.05, then we are good to go for model training. If it is not, we have to make our data stationary, or we have to make the data, the p-value should be less than 0.05. If it is beyond that, we have to do some fine tuning or changes in the data. Okay. Next one is list of time series model. Here I just listed some of the models in this time series, that is AR, autoregressive, moving average, ARIMA, SARIMAX, VAR, VARMA, VARMAX. So this up to SARIMAX, these are univariate model. Okay, the VAR, VARMA, VARMA, VARMAX, and or multivariate model. And for Fourier, we can use it for Fourier profit and Markov chain. These we can use for both univariate and also multivariate, LSTM and exponential smoothing. These are the list of models are available. You can try it out and let me know if you have any comments, if you want any specific model needs to train, that I can make in the future video. Okay. And please to subscribe my channel for upcoming videos. Thank you. Bye bye.